Okay, so hello everyone, and in this video we shall focus on the derivatives of algebraic functions as described by the slope of a line tangent to the given curve, and that is derivatives as a slope of a line. Okay, so let us consider the function f of x described by this curve, and then we shall call a point P, and we know that the directed distance of point P to the y-axis is x, and so point P can be described by the ordered pair x f of x. And we shall now call another point Q, and we shall take note that the difference on the x coordinates between point P and point Q, or that is the change in x, is denoted by delta x, and we know that the directed distance of point Q to the y-axis is x plus delta x. So point Q can be described by the ordered pair x plus delta x f of x plus delta x. And then from point P and Q, I will now draw a line. Okay, so this is the line PQ, and since this line PQ passes through 2 points, then we shall call this secant line. Okay, let's now think that point P is fixed, and we shall move point Q along this curve towards point P. Okay, so there will come to a point that your line PQ will look like this. Okay, and approaching point P, there will come to a point that your secant line will look like this. Okay, and there will come to a point that the line PQ will only pass through point P, and we shall now call it a tangent line. By the way, this line PQ is what we call the secant line. Okay, a secant line is a line that passes through exactly 2 points, and if we move point Q along this curve, okay, there will come to a point that that secant line will now become tangent line. So moving point Q towards point P is the same thing as saying that delta x approaches, that this delta x approaches 0. Okay, now if we wish to find the slope of the line PQ, we shall take note that delta x is equal to x sub 2 minus x sub 1, and then that delta y, okay, the difference on the y coordinates between P and Q is denoted by y2 minus y1, and we know that the slope of a line is given by delta y over delta x, or the change in y divided by the change in x, and delta y is equal to y2 minus y1 over x2 minus x1. Okay, and let us now consider the coordinates of point P and point Q. So we shall now think that the slope of point PQ, or of the line PQ, sorry, is equal to f of x plus delta x, that's your y2, minus y1, that's f of x, that's f of x plus delta x minus f of x all over x2, that's x plus delta x minus x1. So simplifying, the slope of a line PQ is equal to f of x plus delta x minus f of x all over delta x. Okay, so what if we want to find the equation or the slope of this tangent line? Okay, so again, we shall take note of, we shall consider this slope of the secant line PQ, that is f of x plus delta x minus f of x all over delta x. And we know that this delta x cannot be equal to 0, since if the denominator is 0, we know that the function is undefined. So what we shall now think of is that your delta x will just nearly approaching 0 as it gets smaller and smaller when point P, located somewhere here, moves towards point P. One more, when point Q moves towards point P. So your delta x approaches 0. And we can now draw the slope of this tangent line as the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. So we shall take note of this expression as the slope of the tangent line. Okay, let's have some example. If we wish to find the slope of a line tangent to the curve, f of x equals 8x minus 3x squared at x equals 2. Okay, so when you characterize this function, 8x minus 3x squared is a parabola that opens downward. And it is... Okay, so this is the parabola 8x minus 3x squared. And we shall now think, or we shall now consider this point when x equals 2. Okay, so we shall now have a point 2, 4. Okay, so because when x is 2, so you just replace x by 2. So f of 2 equals 8 times 2 minus 3 times 2 squared. And this will give you 4. So the point we are referring to is 2, 4. And out of this point, we shall now draw the tangent line. Okay? So by definition, the slope of the tangent line is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. And then we shall now have the limit of 8, and then you shall now replace x by x plus delta x. So that's 8 times x plus delta x minus 3 times x plus delta x squared, then minus the function itself, 8x minus 3x squared all over delta x as delta x approaches 0. So our goal is to avoid this delta x on the denominator. We shall remove this delta x by simply manipulating the numerator algebraically. Okay, and we shall now have, you just introduce 8 each term inside. So you will have 8x plus 8 delta x, and then you expand this x plus delta x square, and then you will have x squared plus 2x delta x plus the quantity delta x square, and then you multiply it by negative 3. Then you just introduce this minus 1 each term inside. You just have negative 8x plus 3x squared. And then simplifying, we shall now have 8x plus 8 delta x. And then you introduce this negative 3 each term inside the parenthesis. And then you will have negative 3x squared minus 6x delta x. Yeah, that's negative 3 times 2. Yeah. Then minus 3 delta x squared, and then minus 8x plus 3x squared. So what are we now going to do is we shall collect similar terms. For instance, 8x combined with negative 8x will become 0, and then negative 3x squared and positive 3x squared will give us 0. So finally, we shall now have the limit of 8 delta x minus 6x delta x minus 3 times the quantity delta x squared. And what you notice is on the numerator, each term contains delta x. So by common monomial factor, we shall have the limit of delta x, okay, times the quantity 8 minus 6x minus 3 delta x div all over delta x as delta x approaches 0. So we can now cancel this out, okay? And what is left is the limit of 8 minus 6x minus 3 delta x as delta x approaches 0. So what you notice is that there's no more delta x on the denominator. So we shall now replace delta x by 0 by the principle or by the theorems on limits. And we shall now have, if this is 0, so this goes nothing. Okay, so we only left with 8 minus 6x. So technically, the slope of the tangent line is given by the expression 8 minus 6x. And for whatever value of x here, we can draw a tangent line out of this curve. Okay, since the domain of this function is the set of real number, okay, which means x can be replaced by any number, and on those number, we can draw a tangent line. And it means that in a specific function, you can draw infinitely many line tangent to it. And at x equals 2, for instance, then the slope of this tangent line would have been equal to 8 minus 6, then times 2. And that will give you 8 minus 12. Okay, and that is negative 4. So the slope of this line is given by negative 4. Okay, next. But what if we want to find the equation of this line? Okay, so the information we have is that this line passes through the point 24 with a slope equal to negative 4. And if we want to get the equation of this line, we shall now use the point slope form. That's y minus y1 equals the slope, okay, times the quantity x minus x1. Okay, this is the point slope form. Okay, the point slope form of a line. And then where y1 equals 4 and x1 is 2, we shall now have y minus 4 equals, the slope is negative 4 times the quantity x minus 2. And simplifying, you shall introduce negative 4 each term inside. And then you will now have y minus 4 equals negative 4x plus 8. And writing it into the general form, we shall have 4x plus y minus 12 equals 0. So this is the equation of the line tangent to this curve at 0.24. Okay, one more. Another term that I want to introduce to you is the normal line. Okay, so we know that this normal line, as defined, is a line perpendicular to the tangent line. And since this is our tangent line, then I will draw a line perpendicular to it, passing through the same point. Okay, so that's a line perpendicular to the tangent line, passing through the same point. And this point is what we call the point of tangency. This is the point of tangency. Okay, next. And we know that this normal line and tangent line are perpendicular, and given the fact that two lines are perpendicular if their slopes are negative reciprocal of one another. So which means the slope of the normal line is equal to negative 1 over the slope of the tangent line, or the slope of the tangent line is equal to the negative 1 over the slope of the normal line. Given this information, if the slope of the normal line is equal to negative 4, then we know that the negative reciprocal of negative 4 is positive 1/4. So therefore, the slope of the normal line, this line, is 1/4. Okay, if we want to get the equation of the normal line, we shall now use the same form of a line. That's the point slope form. Y minus y1 equals negative 1 over the slope of the tangent line times x minus x1. And replacing y1 by 4 and x1 by 2, we shall have y minus 4 equals 1/4. That is the slope of the normal line times the quantity x minus 2. And then multiplying this by 4. So we shall have 4y minus 16 equals x minus 2. And then writing this as in general form, that is x minus 4y minus or plus 14 equals 0. That's it. Yeah. It's x minus 4y plus 14 equals 0. So what I did is I throw this out on the other side. Okay, so that gives me x minus 4y. Then negative 16 will become positive 16. Added to negative 2 will become positive 14. So this is the equation of the normal line to this curve at x equals 2. Okay. So technically, by definition, the definition of derivatives lies on the slope of the tangent line. Okay. So if we want to get the derivative of this curve f of x, so we shall consider the equation of the slope of this tangent line, and that is given by limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. And this describes the derivative of f of x denoted by f prime of x. And we shall be using the following notation. If y equals f of x, then the notation dy dx, f prime of x, and y prime all denote the derivative of y equals f of x. Okay. So if we want to find the derivative of the function defined by f of x equals x cubed minus 2x plus 3, and then by definition, f prime of x is given by the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. So we now have the limit of, then x will be replaced by x plus delta x. So that's the quantity x plus delta x cubed minus 2 times the quantity x plus delta x plus 3 minus, this is the same function, x cubed minus 2x plus 3. And then again, we shall avoid delta x here. Okay, and then we can eliminate this delta x by simplifying the numerator. And then we shall now have, then x plus delta x to the third power is x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. You shall recall the cube of binomial of this form, which is equal to cube of the first plus thrice the product of the square of the first and the second plus thrice the product of the first and the square of the second plus cube of the second. Yeah. Okay, so plus 3 minus the quantity x cubed minus 2x plus 3. Okay. And then simplifying further, we will have, okay, minus 2x. You just introduce 2 each term inside. Okay, then you will have negative 2x minus 2 delta x, then plus 3, this 3, and then you introduce minus 1 each term inside the parentheses, leaving you with negative x cubed, yeah, then positive 2x, I think, yeah, okay, and then negative 3. And then we shall now collect similar terms, combine similar terms. In this case, x cubed and negative x cubed will give us 0. Negative 2x and positive 2x will give us 0, along with positive 3 and negative 3. And you will observe that the remaining terms on the numerator, all contains delta x. And we shall now have the limit of 3x squared delta x plus 3x delta x squared plus delta x cubed minus 2 delta x all over delta x as delta x approaches 0. So you can now factor out delta x and then cancel delta x on the denominator. Okay, by common monomial factor, we have this. Okay, so you can now cancel this out, and then what is left is the limit of 3x squared plus 3x delta x plus delta x squared, yeah, minus 2. Yeah, and then since there's no more delta x on the denominator, then you can now replace delta x by 0 by theorems on limits. So we shall now have 3x plus 3x times 0 plus 0 squared minus 2, and that gives us 3x squared minus 2. Since this will become 0, this will also become 0. Okay. So which means the derivative of this function, by definition of derivative, is equal to 3x squared minus 2. One more. Say we wish to find the derivative of the function y equals to x plus 1 all over x minus 3. By the same definition, okay, and then we shall now have the limit of 2 times the quantity x plus delta x plus 1. Again, we shall replace x by x plus delta x. Okay, and then all over, you do the same here. You shall replace this by x plus delta x. Okay, and then x plus delta x minus 3 minus the same function f of x. Okay, and then all over delta x as delta x approaches 0. Okay, and then what I will do is I will just isolate first this delta x on the denominator. I will just throw it in front. So that's 1 over delta x times the quantity. And then I will introduce 2 each term inside, leaving me with 2x plus 2 delta x plus 1. Okay, And then you just copy all the remaining terms. And then to simplify, again, we shall avoid this delta x here. So to simplify, we shall combine these two fractions. Okay? And combining these two fractions, we shall get the LCD. That's x plus delta x minus 3 times x minus 3. Then the LCD divided by x plus delta x minus 3 will give you x minus 3. And then multiplied to 2x plus 2 delta x plus 1. Then minus, then 2x multiplied by x plus delta x minus 3. Yeah. Okay. And then we shall now have, oh no, okay. So we shall use the FOIL method, okay, by distributive property. Then 2x times x, that's 2x squared. 2x times negative 3 is negative 6x. 2 delta x times x is 2x delta x. 2 delta x times negative 3 is negative 6 delta x. And then what comes next is this 1 times x is x. Then 1 times negative 3 is negative 3. And you shall do the same here, okay? And then for 1, and then do not forget this minus sign. And that will give you negative 2x squared minus 2x delta x plus 6x minus x minus delta x plus 3. Okay? And then eventually, we shall now collect similar terms on the numerator, which I think 2x squared, negative 2x squared will give us 0. What else? Yeah, it's negative 6x plus 6x will also give us 0. Then there's positive x, negative x will also give us 0. And then this negative 3 and positive 3. And then again, what is left on the numerator is the terms, or are the terms containing delta x. And we shall now have limit of delta x, limit of 1 over delta x times negative 7 delta x all over the quantity x plus delta x minus 3 times x minus 3 as delta x approaches 0. So that is 2x delta x. Oh, one more. This also will become 0. That's 2x delta x, and this is negative 2x delta x. Yeah. And what is left is this negative 6 delta x and this negative delta x. That's why we have negative delta x on the numerator. And then you can now cancel this out. Okay. And what is left now is the limit of negative 7 all over x plus delta x minus 3 times x minus 3 as delta x approaches 0. So we shall now replace this delta x by 0. And that will give us negative 7 all over x plus 0 minus 3 times x minus 3. And finally, the derivative of this function is given by negative 7 all over x minus 3 square. Okay, let's have some more. Differentiate. Y equals the square root of x squared minus 3. So this time, our function contains square root. And by the same principle, we shall be applying the definition of derivative. Okay, dy dx is equal to the limit of the square root of x plus delta x. Again, replace x by x plus delta x square, then minus 3 minus the same function. Okay, all over delta x as delta x approaches 0. Okay, if you have watched my previous video on the theorems on limits, whenever you were given a function containing square root, what we are going to do is to multiply this by the conjugate of the numerator. Okay, so what are we going to do to eliminate this delta x here is to rationalize the numerator. And that can be done if you multiply both the numerator and denominator by the conjugate of the numerator. So we shall now have this. The conjugate of this expression is the square root of x plus delta x squared minus 3. Then this minus will now become plus the square root of x squared minus 3. And then you do the same. You just copy it on the denominator. So you will notice that this is just equal to 1. Okay. So doing it so, multiplying the numerator, so you will notice that this is of the form sum and difference of two binomial with similar term of this form, x minus y times x plus y. And this will give you x squared minus y squared. That is, you just multiply these two, the first and the first, okay? And that will give you x plus delta x square, x plus delta x square minus 3. And then minus, then you just multiply this square root of x squared minus 3 and square root of x squared minus 3, and that will give you x squared minus 3. And then you just copy the denominators, delta x times this, okay? And then finally, what we are going to do is to simplify the numerator. Simplifying it algebraically, we shall now have expand. This is equal to x squared plus 2x delta x plus delta x squared minus 3. Then you just introduce this minus 1 each term inside. So that will become negative x squared, plus 3. And then you collect similar term again, x squared and negative x squared will become 0, negative 3 and positive 3 will be eliminated. Okay, and then we shall now have this 2x delta x plus delta x squared all over delta x times the quantity, the square root of x plus delta x squared minus 3 plus the square root of x squared minus 3. Okay, so you will observe that the numerator, the terms on the numerator contains delta x. So you, by common monomial factor, you can factor it out, and then eventually you can cancel this delta x, okay? And then we shall now have 2x plus delta x, okay? This will now become, this is now eliminated. And then there's only one delta x on the second term, and this delta x is canceled out. Okay, so we shall now have limit of 2x plus delta x all over the square root of x plus delta x squared minus 3 plus the square root of x squared minus 3. And then replacing delta x by 0, so we shall have 2x plus 0 all over the square root of x plus 0 squared minus 3 plus the square root of x squared minus 3. And simplifying further, you will have 2x all over 2. Okay, so when you combine this two, when this is 0, what is left here is the square root of x squared minus 3. And then combine with this one, that will give you 2, the square root of x squared minus 3. And then you can cancel this out, leaving you with x all over the square root of x squared minus 3. Okay, one more. Yeah, sorry for this one. Find the derivative of y equals 1 all over the cube root of x plus 1. Okay. So again, by the same principle, by the same definition, we shall have the limit of 1 all over cube root of x is to be replaced by x plus delta x. So that will become x plus delta x plus 1 minus the function itself, 1 all over cube root of x plus 1 all over delta x as delta x approaches 0. Okay, and then I will first isolate this delta x on the denominator, and then I'll have 1 over delta x in front. And I think that gets a little complicated, okay, but what are we going to do here is we shall get the LCD, okay? We will combine this as one fraction. So combining that as one fraction, you first get the LCD. The LCD would have been cube root of x plus delta x, okay, plus 1. Then cube root of x plus 1, okay? The LCD divided by this will give you cube root of x plus 1. So you have cube root of x plus 1, okay? Then minus the LCD divided by cube root of x plus 1 will only have cube root of x plus delta x plus 1 times 1 will give you cube root of x plus delta x plus 1. Okay, so here it goes. So what are we now going to do is to rationalize the numerator. Why are we going to do that? Because we want to eliminate this delta x. Okay, that is our goal. You just eliminate the delta x on the denominator. And we can only rationalize this numerator if we multiply it by this expression, okay? And this was taken from the special product formula, x cubed minus y cubed, or the factoring technique, which can be written as x minus y times x squared minus or plus xy plus y squared. Okay, so we shall multiply this numerator by this. Okay, okay, so that's cube root of x plus 1 square. Okay, that's it. X is represented by cube root of x plus 1. Yeah, and y will be represented by cube root of x plus delta x plus 1. Okay, so that's this is your x square plus xy plus this will now become your y square. Okay, so we shall have cube root of x plus 1 squared plus cube root of x plus 1 times cube root of x plus delta x plus 1, that's your xy, plus cube root of x plus delta x plus 1 square. And then you just copy the whole thing on the denominator. And you will notice that when these two numerators are multiplied, it will only give you x plus 1 minus x plus delta x plus 1. And that is our goal. So you shall now have x plus 1 minus the quantity x plus delta x plus 1. Because since x is represented by cube root of x plus 1, and you now have cube root of x plus 1 to the third power will only give you x plus 1. So that's why we have x plus 1 here. And then minus, you do the same for the y. Okay, that's cube root of x plus delta x plus 1 to the third power will only give you x plus delta x plus 1. Okay. And then you just copy everything on the denominator. Yeah, it's quite a little complicated, but we can do it. Okay, so to simplify, what are we going to do is to combine similar terms on the numerator, and that will lead us to -1 alone, because this is x plus 1, then this minus will be introduced each term inside, minus x minus delta x, yeah, minus 1, yeah. So you shall have x plus 1 minus x minus delta x minus 1. Okay, and then what is left here, okay, is then this x plus x and negative x will become 0, 1 and -1 will become 0, and what is left here is delta x alone, and then you can cancel it out here. Okay, so which means -1 is left on the numerator. Okay, okay, so then you just copy again everything on the denominator, and then after which you can now replace delta x by 0, leaving you with, yeah, okay, good. All delta x on the denominator shall be replaced by 0, this one, and then where's the other one? Here, and there's one on the last term, so that's 0, okay? And then finally, simplifying, we shall have -1, then this will become cube root of x plus 1 times cube root of x plus 1, then times cube root of x plus 1 square plus cube root of x plus 1, then this will become 0. So this will become cube root of x plus 1, okay, this one. And then for this one, that's cube root of x plus 1 square. And then we only need to simplify the denominator. So when these two are multiplied, this will give you cube root of x plus 1 square. And then you will observe that this one is cube root of x plus 1 square. Okay, and then the middle term is also cube root of x plus 1 times cube root of x plus 1 will give you cube root of x plus 1 square. Okay, and then the last term is still cube root of x plus 1 square. And then when these three are combined, that will give you 1, 2, 3, 3 cube root of x plus 1 square. Okay? And then this is cube root of x plus 1 square times cube root of x plus 1 square. That will give you cube root of x plus 1 to the fourth power. Okay? And we shall have this negative 1, okay, on the numerator. Then you copy this 3, that's 3, and then you multiply this 2. Okay? And this one, cube root of x plus 1 square times cube root of x plus 1 square, and that will lead you to this equation. And finally, yeah, this is the derivative of y equals 1 all over cube root of x plus 1. Okay. Oh yeah, that's it. So you keep on tuning to my channel, and I'll be presenting to you how to use how to find the derivatives by applying the formulas of differentiation. Goodbye, everyone.